Let's go on with our tutorial. Our crankcase, our chassis, is taking shape. We can use both approaches combined, the one for the sheet metal processing, that is, sheet metal features for the bending and forming process, and standard solid modeling features. In fact, now we need to add some holes, so, by the hole command, we make a hole on the face, possibly with designation M5, and type from 2 lines. 2 edges are detected. If we don't want the first one as first distance, we just need to select first line, then reset and specify a new one. We enter 14 mm as first distance and 7 mm as second distance. We don't want extension through hole but blind, and switch depth from 50 to 30 mm and confirm. We make another hole on the other side, this time not by the hole feature, but using mirror solid. We select the feature and apply continue, because we don't have any other features to mirror. We change first symmetry plane into perpendicular to axis and through point, and click on the edge passing through the midpoint and on the midpoint, then we confirm. Let's now check if the object can be unbent, that is, if the features made so far allow the unbending of the object. We apply the unbend command and change type from global into local, and indicate the face to be kept fixed and around which the program will calculate the flat pattern. We also indicate the bends 1 or 2. The program takes them into account to unbend the object. It hasn't been unbent completely. We had selected local type, and the object is unbent in part, as we can see by the command preview. We exit without confirming. For sure, we have an interference between the engine and the top flange. That's why we select the face on which we position the work plane. Let's switch to the 2D profile environment. OK, we enlarge the area and create a rectangle. We don't bother entering any driving dimensions here. We just need to understand the goal. We know that we can insert some driving dimensions to determine the sizes of the rectangle, its position from the edges, and so on. Now going back to the model environment, because from the rectangle we need to make a linear slot, we do it, not through hole, but through next, piercing only the top flange and not the bottom one. We click on the arrow and confirm. So far we have inserted some solid modeling features. We need to add some more, but on the object after unbending it. That's why the command is unbend. We click on the fixed face with global type and confirm. We unbend the whole object because we need to create a set of slots. Manufacturing will be actually made by punching machines on the flat sheet metal. That's why we position the work plane on the face. We go to the 2D profile environment, enlarge the area we are interested in, create a rectangle, and enter some smart dimensions. Height 20 mm. Here we are. For the width 5. OK. Now we just need to define positions. From the right side to the edge, we set a distance of 8 mm, and from the top side to the edge of the bend, again 8 mm. OK. Let's go back to the model environment and make a linear slot, this time using the through hole option. OK. And we confirm. We enlarge the area and pan over the solid. We create a solid pattern, selecting the feature to replicate in the history tree, and select continue as before, it's the only feature to be patterned, with linear type, of which the first direction is the one inwards. We set fit for placement, so we are prompt for the first extension. We enter 80 millimeters, and for the first number of copies to add, we enter 8. As second direction, we use the edge as a reference, drag the patterns to the other side, where we specify second extension, 75 millimeters, and 3 second number of copies, and we apply. The feature was performed on the unbent object. We change visualization once more, and by the reband command, we reband it, selecting the fixed face. OK. Now let's see how these slots will be on the object once it's bent. Let's now insert another slot. This time is in correspondence of a bend and a tilt and flange. We place the workplane on the top face, switch to the 2D profile environment, changing visualization, and zooming in on the area we are interested in, and create a rectangle. OK. We want to center it both horizontally and vertically by a coincidence constraint along Y between the midpoint of the right side and the midpoint of the band. Then, by a coincidence constraint along X between the midpoint of the upper side and the midpoint of the edge of the band. In this way we center the rectangle and we close the command. We go back to the model environment because with this rectangle we'll make a linear slot with a blind single depth extension 20 mm deep, and we confirm. And this is the result. Now we apply the unbend command. We change visualization and click on the face as fixed face for reference. OK, we confirm. Let's position ourselves in workplane view. OK, we move the solid and enlarge the slot area. We notice that the slot we made in the object generates a tilt face. However, to build up the part, it's more appropriate that the side faces are vertical. To make this change, we must select the solid, then from its properties, the normal side faces parameters. Previously we had unchecked it on purpose. OK. And we confirm by OK. Let's see how the face has been modified on the object folded. Now we reband the model by using the reband command, selecting the face and confirming. The object is over, and we must create a drawing with this flat pattern view where we'll add dimensions and so on. How? Right-clicking on the solid in the history tree and flat pattern view. And now we are in the drawing environment. Another right-click again, this time close to an angle of the object, and we select Edit Properties, then Flat Pattern to manage the view. For instance, we can state we don't want to see band lines, band data, and reliefs exceeding a value calculated by thickness factor 1.5 multiplied by 4. OK. In practice, we ask not to show band lines, band data, and reliefs because this drawing will be used for laser cutting, which will not make reliefs. They will be made by a second phase by specific punches and so on. In the flat pattern properties, we reset the default values, band lines, band data, and reliefs, and rotate the view by 90 degrees. OK. In this way, the view orientation is now being changed. All right. We zoom in for the detail. OK. Then we go back and adjust the scale again to create some space for a table. Instead of having band data on band lines, we can insert a band table of the view. We indicate it in a specific point, but again we indicate. OK. We zoom in to the table contents. What happens? We can see band lines are numbered. For instance, band 5 and band 6 have a specific value, 55 degrees. Of course, the table is related to the model. What does it mean? It means that if we switch to the model, click on the flange, and ask to show the driving dimensions, OK, and do the same for the second one, then we set 15 for the angle of 10 degrees and confirm, and 75 for the other, currently 70 degrees, and rebuild. The model is updated accordingly, and so are the band values, of course. Now let's view the object from one side to better appreciate the changes, and switch back to the drawing. OK. We are asked to rebuild the drawing, and we can see that bands number 5 and 6 changed according to the changes made on the model. OK. We close the model without saving. Now we want to bring again the orientation value of the first flange to 10 degrees, so we redefine the feature, open local properties and more options, and modify the angle from 15 to 10 degrees. Then we rebuild. Now we change the orientation value of the second flange as well to 70 degrees and rebuild. We change visualization, and using the selection filter, we select profiles only. OK. After that, to hide entities, first we select them. OK. Then, from the menu bar, we enter View, Hide Entities. OK, here we are. We can save our model with the final results.